Hello, we're looking at problem number 1 found in section 4.6 of your geometry textbook. This is found on page 260. In problem number 1, we're going to be using what's called the HL theorem, and the HL theorem is referred to as the hypotenuse leg, and this only works with right triangles, trying to prove right triangles are congruent. So if you have a right triangle and you know a hypotenuse and you know a leg of one triangle and it matches the hypotenuse and leg of another triangle, then that's enough to prove that the triangles are congruent to each other. Now, excuse me, let me get this. Now, we're looking at an example that on a basketball backboard brackets shown below, ADC and BDC are right angles and AC and BC are congruent to each other. And it's asking, are triangle ADC and triangle BDC congruent to each other? Now, we're talking about the back brackets here of a backboard. So they've just kind of blown this up so that you can kind of see what we're talking about triangle-wise. So we're saying that these two angles right here are right angles, and we're also saying that this is congruent to this. Okay. Now, as we progress along a little bit in this and move down a little bit more, and I know the picture goes out of sight a little bit, we're given that those two angles are right angles as I showed you above. And so we know that these two triangles are going to be right triangles, and that's very important because you can't use hypotenuse leg if you don't have right triangles. We also know that the hypotenuse of the two triangles, AC and BC, those were given to us as congruent. That was already given. So we know that we have a hypotenuse of each triangle congruent to each other. Now if we could just find a leg that was common. Well, DC, which is the middle leg between the two triangles, is a common leg to both triangle ADC and BDC. So DC is congruent to DC by the reflexive property. So let me quickly move that back up just for a second to show you. We're talking about this segment right here. DC is congruent to DC, and it belongs to the top triangle as well as the bottom triangle. And yet it belongs to, it is equal, of course, to itself by reflexive property. And so that's enough information for us to say that those two triangles are congruent to each other by what we refer to as the hypotenuse leg theorem, because we have a hypotenuse and a leg of one triangle matching the hypotenuse and leg of another triangle. All right. Now, let's look quickly at this particular picture here. We know that PRS and angle RPQ are right angles, and they've got those marked accordingly here. We also know that SP is congruent to QR, which is also noted with the little tick marks there. So that's congruent to that. And we're going to try to prove that these two triangles are congruent to each other. Well, the only other thing that we need to prove by this is again, if you think about the left triangle and the right triangle, this is the hypotenuse, just like this is the hypotenuse. And of course, this proves that it is a right triangle. So does this. So all we need is one more thing. And the one more thing is, if we look at this side right here, PR is congruent, of course, to itself, PR, because of the reflexive property. Any segment is congruent to itself, and that belongs to this triangle as well as it belongs to this triangle, and that is referred to as a leg. So we have a hypotenuse and leg of one triangle congruent to the hypotenuse and leg of the other. So these two triangles really are congruent to each other by, again, the hypotenuse leg theorem, just like the example was. Okay. Now it says, your friend says, suppose you have two right triangles with congruent hypotenuses and one pair of congruent legs. It does not matter which leg in the first triangle is congruent to which leg in the second triangle. The triangles will be congruent. As long, they may look different. You may have a right triangle here and one laid this way, and this triangle, as long as one of the legs match up, then it really doesn't matter. So the friend would be correct, even if it doesn't appear, to be. As long as you have a hypotenuse and a leg, regardless of the legs looking the same or not, as long as if we know they're congruent, that's enough to prove that the triangles are congruent to each other. All right, I hope this was helpful.